And good morning to everyone. And it's a Friday, and seems like it's chaotic, and it's got to settle down. We had questions that were asked after class from the last meeting, and we're going to talk about that. We were listening to Dire Straits and Ticket to Heaven, right? Okay, so this morning, if I can keep microphones from tangling with the books and such, we're in business. The question about slope, we need to go back and look at that some more, I think, from the way everything seemed to go in questions after class yesterday. So let me talk about a few items there again, what we mean by slope. Slope involves an equation. We talked about that in class, so let me write that again. So I need to get this a little bit cleaner than it is, so let me see what I can do. Never did get time to finish the erasing, so I'll try to go as I go along here. But the slope is also designated with the symbol m. And the slope is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, the argument here is that we have 2 points, and the 2 points are graphed on a coordinate system so that the first point is to the left of the second point. So in that sense, I look at a coordinate system, and this is not the most elegant one, doing it freehand, but the idea is I have some point 1 and some point 2. Now, the ordered pair for this point on the left is going to be x sub 1, y sub 1. So there's that consistency. And the ordered pair for the second point is x sub 2, y sub 2. Now, the simplest way of deciding which is x1 and which is x2 is to ask which x is the smaller value. So as an example, let's assume that point 1 is defined by the ordered pair 2, 5. And point 2 is going to be defined by the ordered pair, and I'm just going to put 7, and here I'm going to put 11. So 2, 5, 7, 11. Now with the notation, I've argued this will become x sub 1, y sub 1. Because I've defined this point to be point 2, it is x sub 2, y sub 2. Technically, it is not, it's not critical which one you call point 1 and which one you call point 2. So I could reverse this notation. But at the same time, you need to realize that when things are done in mathematics, x1 is going to be smaller than x2 in most of what you read. So if you're planning ahead and learning stylistically how things are going to be presented, then I think it's important for you to locate your first point so that its x value is lower than the x value on your second point. Now, once you have your equation, and what I'm asking you to do is to write the equation in which you write y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I then expect you to substitute. So if I then substitute in this problem, all I have to do is look to see what was y sub 2. It is 11. The y sub 1 is this value, so I'm going to subtract 5. Then I'm going to come down to the x sub 2, which I've already identified, and that is 7. And the x sub 1 I've identified as 2. So once I make my identification, there is no particular confusion. If I look now, I have 11 minus 5, so my slope is going to be 6, and I have a 7 minus 2, so I'm going to have a 5, so my slope is 6 over 5. Now that's the process, I expected you to plot the 2 points in question, write the equation for the slope, substitute, and find the answer. Now, we also indicated in this process that there is an interpretation of slope that is very commonplace, very important, and that is to look at slope as the rise over the run. Now, if you look at it as rise over run, conceptually it's a good idea. But from the standpoint of notation, if you limit yourself just to that as a concept, you wouldn't be getting enough. That's a very important consideration. We are going to, as I've already told you, we aren't going to do it yet, it's done actually in a later chapter. We are going to take an equation and write it in this form, which we talked about. That, remember, was starting with ax plus by equals c, and we were going to transform it into this form. And the coefficient of x is this very slope we're calculating. So if you were to look at one of the graphs you were doing, and I'm going to illustrate, for example, with, I think, y equals 2x, in the problems I just returned, I think we had a, well, I'm going to write it this way, y minus 2x equals 0. It may not be the exact form the problem was in. Very similar to that. Now, you were asked to plot that. Now, as it stands, you can go ahead and you can just substitute. Now, some of you were getting a little bit sloppy in your substitution and keeping track of what's x and what's y. So if I make my table with x and y, and I indicate that if x is 1, then y minus 2 must be 0. So that tells me that y has to be 2. Now, it's sometimes easier to do this by taking this equation and writing it as y on one side, and I think you might prevent some of the traps I see in several of your papers where you reverse the ordered pairs. I want to talk about that in a moment. But now if I let x equals 1, do you see how much easier it is to see that y is 2?
Yeah.
If x is, for example, 3, then y is 6. And what some of you avoided, like it was the plague, was letting x equal 0. Now, when you were asked to do the intercepts, that was a different story. But in general, if you can, by substituting 0 into the problem, get a value for y, that's a freebie. And that's the easiest it gets. Don't let the easy slip out of your hands. Now, some of you drew graphs, and because your scales were not uniform, you were giving yourself a perception of something that was not valid. In this particular problem, I hope you realized that I could add a 0 here and not change anything. What I did was add a 0 to the 2x. Now, my point being, this tells me that y equals 2x plus 0 is the same equation. I know the intercept is 0. I know that that line must cross the origin. If you graph these 2 points, the first 2 points, 1, 2, 3, 6, and your scale is not carefully drawn, your line may not be going through the origin. And in several papers, I just simply circled the origin, indicating to you that your graph was misleading. The most important characterization of y equals kx. What do we call this? Y equals kx. We had a name for it. It wasn't in this section. An earlier day. It is a direct proportion, right? Y equals kx is an equation for a direct proportion. We say y varies directly as x, and we say k is the constant of proportion. So in this case, the constant is 2. It doubles everything. So if it takes 2 minutes to do each problem on a quiz, and I give you 12 problems, you know it's going to take 24 minutes. That's direct variation. Well, the idea in this then is that your graph should include the origin. A couple other asides. When you plot the points, you must join those points in a straight line. It is not sufficient just to plot the points, because we are not restricting ourselves to integers. We are saying x can be any real number. The fact that you, as a convenience, use x as a counting number is to make your life easier. But you have to understand that x could be 1/2, it could be 1/3, it could be the square root of 3, and this still holds true. Okay, so when you are graphing the line that goes with this linear equation, you are interested in showing the entire solution set. There's a lot going on here, but in the process, when I wrote y equals 2 over x, I want you to realize that I could have written it that way. We'll slide over just a little bit now. Thank you, Ernie. 2 over 1 times x. Now this says that the slope is 2 over 1. That says for a run of 1, your rise is 2. Now, one of the things that comes out of this is the fact that you can now start plotting points. And even though we haven't technically worked with this area, if you have a rise of 2 for a run of 1, that means this line is going up to the right. We talk about positive slope. Now that tells me, as I go from left to right, from point 1 to point 2, and that's why it's important that point 1 is your first value on the left side. As I go from P1 to P2, the fact that I have a positive here says that the line is rising. You are going uphill. So when I graph, and let me again try to clean up piecemeal as I go along here, or the photographs will not come out as nicely as I'd like. If I then look at the graph associated with this, and I have x and I have y, I'm arguing that my first point was 1. Let me get the scale here reasonably uniform. So if I'm going to 1, 2, this is my first point. Now that's P1. As I go to the next point, which is 3, 6, I go over 3, then I'm supposed to go up to 6. Well, if this is 1, 2, 3, 2 units of that puts this up here at the second point. It is going which way? As I go from left to right, as I join these two with a line, see if I can now darken that in a little bit. Okay, scale is such that I had to dearly create a bend there. It's going through the origin. This is the first point. This is the second point. As I go from P1 to P2, the line is going upwards to the right, positive slope. So when I write something, y by itself, and I see a positive, I've got to see a line in this orientation. Now, I think another one you had was y equals negative 6x. Is my recollection. What does that tell you about what your graph should look like at the end? Downhill. As you go from left to right, you're going downhill. So if I look at this graph, x and y, and I take 0, 0, I'll just take the easy one this time, when x is 0, y is 0. And now when x is 1, I'm supposed to be at what? When x is 1, what's my value? Come on, you can eyeball that. X is 1, y is negative 6. So 1, then 1, 2, 3, 4, 5, 6. Here's my second point. Now, as I join those, and boy, it's very obvious that I did not make that parallel to the board, the edge of the board, and I'm trying to get something that looks reasonably good. But the argument is this is going downhill. Okay. It's supposed to be a straight line there. If I had a straight edge, it would look a lot cleaner. But that is a kind of understanding that ties together with what some of you are doing as a kind of karaoke. Plot the points, but not have an idea of what you're creating as you plot those points. And I want a little better understanding of what you're drawing in the process. Slope and intercept. It's not a big deal. It's very appropriate at this point to mention that if you solve for y and get y by itself, the coefficient of x is your slope. Now, it's not at the moment something that you can use particularly easily. Bad choice of combination there. It's not something that I think you will find easy to implement. Knowing that you're at the origin because it's plus 0 and your slope is 2 over 1, but I'll just show you what I would do here. If I'm at the origin, because the intercept is 0, the slope of 2 over 1 says I'm at this point. I want to get to another point. It tells you go this far over and go this far up, over 1 up to second point, I'm done. And that's referred to as the point slope form of graphing a line. No ordered pairs. You just get your intercept. You know your slope. You get your next point. So the intercept is 0. Tells me I'm at the origin. The slope is 2 over 1. It simply says that if I have a run of 1, I should have a rise of 2. That gets me to another point in the line. Join the 2 points, and I have my graph. Beats the heck out of plotting points. Fast and efficient. Now, we'll be doing that later in much more detail. You get a chance to practice it. Right now, I just want you to observe that if you have positive slope, the line goes upwards to the right. If it's a negative slope, it goes downward as you go to the right. There are 2 ways of getting slope. One is to solve the equation for y. The coefficient of x is the slope. The second is to take 2 points on the line and use the equation. And let's slide over now, Ernie, or use the other camera to get to my equation where I have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'll let you make that cut. This, as we come up here, is my formula. You have 2 points. You just plug it in and get the answer. Does that provide a little better explanation for you on slope? I did that very quickly yesterday with the hope that things would go smoothly, and I overestimated what I think is maybe the difficulty that might have been doing that as a calculation. Do you have other questions you would like to ask from the homework? Yes?
Can you do number 48, page 198?
Okay, so 48 on page 198. Well, let me get that up on the document cam here in just a moment. So page 198, if everybody will get to that problem. And we're looking, I guess it's actually in 199, correct?
Oh, yes, sorry.
But the idea is there. Okay. The demand for an item is a function of its price. When the price goes down, demand goes up. Okay, let's let that just sit there for a moment. Am I in the right problem?
Yes.
Okay, as we come off the document cam now. What topic does this go under in econ? Economics. Supply and demand theory. Okay, now the argument is if I lower the price, I should what? Sell more items.
Right.
If I raise the price,
Less.
fewer items. It's interesting, one of the little anecdotes out of technology has to do with software. Let me consider the following problem. I have written a word processing package. Now, the one that probably comes to your mind these days is Word, Microsoft Word. But now I'm going to show my technological age, okay, which is antiquity nearly. WordStar. Okay, boy, I went too far back. Even people who are familiar with technology are going, huh? Okay, name me another one then, still done by Lotus as part of their suite. What?
WordPro.
Okay, AMI Pro is done by Lotus. Okay, so the point being, there are others. There was one that was sort of between WordStar and Microsoft Word that was very, very popular and had market share. Wasn't it WordPerfect?
WordPerfect.
WordPerfect actually had market share, just like Lotus at one point had market share on a spreadsheet. And then came along Bill Gates, who seems to have a knack for taking anybody's market share and absorbing it, even if they don't buy the company. Well, let's say that I've come up with what I think is the latest and greatest word processor. I argue that it's better than anything Bill Gates has done, WordPerfect, AMI Pro, anything. My price for the item, $10.
Wow.
What's your first reaction?
Buy it.
What's the catch?
Okay, there we go. What's the catch? And it must what? Not be very powerful, because if it were, you would charge more. So I've produced this, and I'd like my sales to go up. What's the simplest way of doing it? Raise the price to $100 a copy. Now I'll sell it. Okay? So my point, supply and demand can be what? A little bit dicey here. Typically, probably a good idea. But we are saying that the demand of an item is a function of its price. So if the price goes up and the demand goes down, what kind of variation? It still is direct variation, but if you think of this as a proportion problem, the value of k will be negative. Y equals kx. Okay, in the sense you're arguing that as price goes up, demand will go down. Okay? There's a word in here I'd like to address, and it relates to something else that took place in your homework. Okay, let me first see if I can get this tighter so that we can see the word I want in nice, big, bold print. Okay. The word function. A function of its price. I'm going to have to come to the sideboard because I've managed to chew up everything in the front board already. A function. And I can't, since the question was asked, I can't pass up the opportunity to talk about this word. First, the question. In mathematics, what is a function? And in a very simple way, the definition is a set of ordered pairs. Okay, so when we talk about a function, we really talk about a set of ordered pairs. And the word function of its price would be translated in the following way. If I let x equal the price, then I'm arguing that to say the demand, and I'm going to let y equal demand so that we have x and y in our usual way. When I say that demand is a function of price, I can say y equals f of x. And that's the notation. Y equals f of x. And you're going to find this notation used throughout mathematics. So a function is not a word that just is taken lightly here. It says you have a set of ordered pairs in essence, and there is a rather important caveat to this phrase, a set of ordered pairs, where for each x there is only one y. So if I give you x, there's only one y you're going to get. That's going to be a function. If I have an x, I cannot get two different demands. If I have a price, there are not two demands that go with it. It's a unique demand that will go with that price. So my language here is y equals f of x. Now, relative to the problem, can we come back to the document cam now, Ernie? I have some information that's going to help me determine what set of ordered pairs that are involved with this problem. Now, it tells me something that when its price is $30, what do I have? What kind of demand?
8,000.
1,000, right?
Yeah.
Just taking that one phrase. And unfortunately, I'm getting a lot of glare. Let's see if I shade this. There we go. Shading the page a little bit from the light. We have a demand of 1,000 when the price is 30. So what is that giving me? An ordered pair. But you have to be careful. Which is x and which is y?
X is the money.
X is the 30. Y is the 1,000 the way I've done it. Okay, let's come off there for a moment. Now, and then additional information, coming back to the problem. 8,000, again, I've got to get the glare. It's 8,000 when what? When we have 15. So what do I have? Two ordered pairs. So I'll leave that there for a moment. I'm going to go back to the sideboard, or over to the sideboard. And let's leave that on the, just for a moment, that I had 8,000. So I have 15, comma, 8,000, correct?
Right.
And then I also have what? 30 and
1,000.
1,000. Now, do you see in this process, and I avoided using a comma for the 8,000 and the 1,000, but do you see as x goes up, y goes down? Slope is what? Negative. Direct variation. But if I'm looking for the slope, I'm going to call this point 1 and this point 2, correct? Now, what am I asked to do in the problem? What is the problem asking me to do? Somebody paraphrase it for me.
Graph
The two given pairs.
of prices and demand.
I want to do what now?
Graph.
Okay, I've got the two pairs. I can graph those. And then what am I supposed to do? Anything else?
Assume the relation. The next part is assume the relationship is linear. Draw a line through the 2 points.
So you're drawing a graph in which you plot 2 points, join the 2 points, giving you a line, and that line is going to be representing an equation that you could create, right? Did you graph the line? Will you look at your homework paper? You plotted 2 points. You're supposed to graph the line, and I'm going to push the problem further since it was asked. I'm going to get a straight edge because this is going to require that I be a little bit neater than I've been so far. Now, graphing this may require that you do what with the scale? You might want to say that we are going to let the y value be times 10 to the third. Otherwise, you're going to have a heck of a point graphing. You don't do something like that. The x value, I'm okay. Now I need some units here. So I might decide to take a scale such that these are by 5. So I have 5, 10, 15. But if I do that, you realize I'm going to be way out in the boonies by the time I try drawing this. So instead of that, I might say, okay, let's make this 10. Let's make this 20. And let's make this 30. Do you see how by choosing your scale, you can make it more amenable? Now up here, I again have a problem because I have 1,000, 8,000, and all I have to do is have 1 through 8. So I might decide to take this by 2, 4, 6, 8. So this is going to be an 8 here. This is going to be a 6, a 4, and 2, but I'm really talking about 8,000, 6,000, 4,000, 2,000. So I've made the scale so it fits my paper. And now, at 15, which is here, I'm supposed to be up to where? 80,000, which I'm going to represent right here. That's one of my points. Now, that's my point 1. Now, for point 2, I'm at 30,000, and then what am I supposed to be down to? 1,000, correct?
$2 and 1,000.
Is that right? So I have a second point right here. I hope that that scale is appropriate. Now, I'm making these dots big enough we can see them on camera. But that's what you were supposed to do with this problem. Now, I join those 2 points. I think you were asked to do that, correct?
Mm-hmm.
That's as far as you carried the problem. Could you get the slope of this line at this point? Were you asked to do that in this problem? That's a shame. But we could, right? What would the slope be? Well, the slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What are we going to get? Okay, this is y sub 2 now, right? So I'm going to take 1,000 minus 8,000. So 1,000 minus 8,000. And what is the difference in my x's?
30 minus.
Y sub 2 is up here, the first one. This is x sub 2, so that's going to be your
15.
30. And then minus
15.
the 15. Now, with the scale I've done, technically, I'm going to get rid of the zeros here because my scale is graphed in what? Relative to thousands. So if I do that, then I have a negative 7 over 15. That is my slope. Pretty easy to get, right, if you have 2 points? Okay, now let's go a little bit further. This one's not so easy to do, given the space I provided. I'm going to just dot this here so that I still can read what I have up there and dot this. Now, right above that 3, I'm going to point to it with the meter stick, is where the line crosses the vertical axis. Can we get an estimate of that using our scale? Well, I think we can. Here, just make some more marks going up. And it looks like 10, 12, 14. Now, I'm just eyeballing. But it looks like the intercept is 14. What could I do immediately knowing the slope and the intercept? I mean, this is just one more step, and it's such an easy step. What could I do? Okay, Ernie, I'm going to need your help. The y equals mx plus b, slope equals rise over run. Can you zero in on that on the front board for me? Middle of the board to the right of the clock, slope equals rise over run, and then it has an equation y equals mx plus b. That's the part I'd like you to catch for me. We're in the middle of the board, and there's an ax plus by equals c. Okay, I think I've got Ernie going to the right spot. Thank you. Y equals mx plus b is a slope-intercept form. So leave that there for a minute, Ernie. And what I'm going to do on the sideboard, and then we're going to look at the sideboard, is write this new equation using the information I had. There it is. Y equals negative 7 over 15x plus 14. Done. I now have an equation of the line. Now, how accurate is it? The slope I'm comfortable on. The intercept, that's debatable. This says that if you sell it for no money, you'll still what? Only sell 14 items. I don't know if that's a reasonable statement. You ever been to a business trying to go out of sale? And they drop the price and continue dropping the price, and you see something at a nickel, and it's sold for $40? Sometimes people still won't take it. Okay? They just don't need it. So there's a limitation to what is reasonable here. To say that you have no price on the item, you only sell 14,000, there's a point at which people just don't need an item. If you were right now to have, I'm trying to think of something that's pretty useless. Are you familiar with the old floppy disk before the 3.5 inch?
5 1/4.
The big ones, the 5 1/4.
Oh, yeah.
I'm getting some people nodding yes. Most of you are saying, no, don't remember that. Folks, it wasn't that long ago. The 3.5 inch rigid floppy had a predecessor that looked like a CD nearly, but it was very floppy, literally. It had a cardboard outer cover that was sort of squarish looking, but it was very bendable. Let's say you had 14,000 of those, and you dropped the price to zero and said, I have 14,000 5 1/4 floppy disks. Take them! What's going to happen?
Nobody's gonna take it.
They're going to sit there, because if you're still using a computer with a 5 1/4 inch floppy disk, you probably aren't doing much with it. They become great doorstops.
Good coasters.
What now?
Good coasters.
Yes, coasters. Okay, coasters work just like the CDs. And something to be said for them. Okay, that's an interesting problem. I carried it further than you were planning to do so, but does that answer the question on 48 that was asked?
There were 3 parts to that. That's
Well,
main
the
part.
third, okay, assume the relationship is linear. Draw a line. C, use the graph to estimate the price of demand for 4,000. I didn't do that.
Well, in B,
If the demand is 4,000, part C, we need to maybe look at that graph again.
well, it also says in B, from your graph, estimate the demand and price drops to 10.
Okay, so we're going to use the graph to try to get some estimates here. So we'll come back to that in just a moment. But I would like to indicate to you this is a continued effort to answer Perry's question from yesterday about the utility of graphing. And this is a case where we're looking at supply and demand theory from econ. So let's go back to that graph. Now, one of the important things that you'd be able to do, I think I contracted that sentence in an unfair way, you should be able to take a graph like this and interpret information from it. So if I had X was $10, is that the question? To estimate the demand? Now this is a process I expect students to be able to do in a stat course. If X is 10, you draw a vertical line until it does what?
It crosses them.
It crosses the line. Then you do what? A horizontal line coming over, and then you're what? You're going to then interpolate, like I did up here, what the appropriate demand is going to be. Now, from the scale I have, and I hope yours is a little more precise than mine is, I would estimate very close to 10. Now, I think I look at my scale, and I don't think I had it quite as uniform as I should. To the nearest, I would argue that is going to be a demand of about 10,000. Now, we can do what? Work backwards, which is to do what now? Take a demand, otherwise you want to sell 40 items, so what's the point? How much should you drop the price? You see the relationship here. If you know that this is a linear relationship and you have 40 items to be sold by June, then there's my 40,000, and I'm coming this time across to the line, and then I'm going to drop a what? A vertical, and I'm a little bit concerned about the value I have here, because it looks to me from what I've done and the precision I've used, but I'm saying about $22.
There's one got 24.
Now, if you did a little more precision, because my 25 is about here, and maybe 23 from what I'm doing, maybe 24 somewhere, I would have trouble because I did not put the finesse into this. But if you are very careful, you can argue that $24 then is going to be the price that will result in 40,000 items being sold. Now there's a problem here because what happens is you saturate the market. Rather than having continued increase in sales, it can level off and you can end up with an inventory that's not selling. So there's a lot in this model to be left desired. Now, I want to move over to the right here a little bit. Remember, I talked about a function. The argument was that if I give you an x, you can do what? Give me a y? Agreed? Now, what did we just do in this last part of problem 48?
Oh, we have a y. We got an x.
They gave me a y, and I had to do what?
Find the x.
Find the x. Agreed? We reverse the process. Okay. Now, what was my definition of function again?
Set of ordered pairs.
Function, a set of ordered pairs. So equals a set of ordered pairs, x comma y, such that each x gives a unique y. Now that statement is what I said earlier. I give you an x, you give me the y. What happens if I want to go the other way? Where each y gives a unique x, because that's what we just did, correct? That's going to be called an inverse function. Not a reverse, but an inverse function. And that's going to be very important for us later. But this is a nice place to first introduce this idea. Because we looked at a y, now give me the x. Here's what we do. Now watch this next, because this is just a matter of reversing two symbols. I started with this set. In essence, I reverse the x and the y to a y and an x. This now becomes the inverse. How important is that? As the semester goes along, that you'll be accountable for in the final. Okay? And this is a nice place to introduce an idea. So again, I'm trying to take some ideas that we get out of these problems and sort of look ahead. Let me tie just a bit closer to that. Okay, this is from yesterday, pulling pieces together again. Remember that equation? We contrasted that to y equals x, and I said that was a parabola. Then I said, with enough wine, you might do 2 to the x. And I said that gave growth, population growth. This is the Sessa's reward problem I talked about, where you keep, you start with a penny, then go to 2 pennies, then go to 4 pennies, and so on. That curve I mentioned to you looked like this. What was the name of that curve? Looks like a jet taking off. I had a name for it. When you hear people talk in California or in the world about growth, they use a phrase with it, some kind of growth.
Exponential.
Exponential growth. It's sort of like doubling every so many years. That would be exponential growth. Now, when I did that, I mentioned to you there is related to that another graph. And this has to do with earthquakes. So this is all California talk. Earthquakes. A logarithm. And those two graphs look a little bit like they're symmetric to a line going through the origin, y equals x. Now, I'm going to try just very briefly a function, reverse the ordered pairs, you get the inverse function. If you have an exponential and you reverse the ordered pair, you get this graph. That's what you do in intermediate algebra. So intermediate algebra takes this whole idea right here and spends much of the time covering that material. So it's an outgrowth of things we talk about right now, and the idea is this is well beyond where we want to discuss as a depth topic, but when you talk about something being variation, direct variation, it's like a linear equation. Some things don't vary directly. They vary exponentially. So again, if you double the amount of money you get in a job each day, things grow very quickly. Now, Perry, you said that Excel gave you a $10 million total for the month? The answer to yesterday's question was $10 million for the month. You start with a penny the first day, 2 cents the next day. The third day, you're only getting 4 cents. Fifth day, you're only getting 8 cents, and then it goes to 16 cents. And you're going to work a month for me. But by the end of the month, you'll make $10 million plus dollars. Okay? Isn't that neat? 10 million is a lot. I mean, even for Bill Gates.
For a month.
Yeah, for a month. I mean, that's just 1 month. Of course, if you kept the job for a year.
Maybe you change your pay.
Right, then you can do anything you want. Other questions on the homework? Now, again, what I'm trying to get to in much of what we've did today, and I'm just using this as a day as makeup. We had topics I needed to cover in more depth. I needed to answer questions from the homework. There's still a bit more I want to cover in the time that's remaining, but we are just going to stay in 3.3. We aren't going into 3.4.
Can we just take a look at 16 on 208?
Okay, 16 and 208. We'll leave that there, and I'll go over to 16 on 208. Number 16 on 208. Okay, I'm having trouble with the camera and my...
I think the problem I was having was not getting the answer, but the graphing out.
Okay, so we have 16. We have 4 minus 1 and minus 2 minus 8, right?
Right.
So we have 2 ordered pairs. By the way, which is point 1 and which is point 2? The way we've tried to work this.
Second one is a point.
Okay, the minus 2 minus 8 would be P1 because it has the x to the left. 4 comma minus 1 is P2. And so with that, I take it now, if I'm understanding the question, the slope was not a problem. It's graphing the 2 points?
Well, I guess I did it backwards because I took first set.
As P1? Okay, it can be done, but it's going to, I think, create more confusion than it should.
Obviously.
And if you plot the points, let's look at the points again. As I look at these ordered pairs, now thinking of as an ordered pair as a point may bother you, but that's our argument. Is this a positive slope or negative slope as you look at it? We went from negative 2 to 4 for x, and what happened to y? It went from negative 8 to negative 1. Was it going uphill or downhill?
Up.
Okay, it's uphill. Positive slope. Again, as you just look at those pairs, I think of starting with minus 2 minus 8. Now, as I go from minus 2 for x going to a positive 4 for x, I'm asking what happens to y?
Down.
It started at negative 8 and then does what? Goes to negative 1. That means it's going up. Hence positive slope. Okay? No. Okay. Let's see if I can get something to work here. Okay, let's try that, Ernie. The glare is a problem for me there. But then again, let's look at the ordered pairs. I'm arguing that point 1 is negative 2, negative 8. Point 2, I'm going to argue, is 4, negative 1. Now, using that as a convention, it makes it a little bit easier to ask the question. What happens as I go from P1 to P2? X changed which way? It got larger, correct? So as X got larger, what happened to Y? Did it get larger? is I went from a negative 8 to a negative 1. Isn't negative 1 a larger number than negative 8? See, that's the problem where we think in terms of negatives, and sometimes we look at magnitude in absolute value. We see an 8 and a 1 rather than a negative 8 and a negative 1. Let me get the straight edge again. Let's plot it. Now this is what number again? 16? Page 208. I'll just write that up here so when it ends up on the photograph, it will be a little more readable. And a scale quickly. So I want, maybe by 2s. Well, let's do this. I think we can get by with that. So that is going to be negative 1, negative 2. Then using the same scale, 1, 2, 3, 4. So this is over at 4. So I've gone from here to here on x relative to where my x's are. That was an increase. Now I need the same scale here. 1, 2, 3, 4, 5, 6. That figures. Okay, I'm going to unfortunately do something I don't really like having to happen here. I'm going to have to count by 2s, so I'm going to change this to negative 2, negative 4, and call this 8 out here, 6, 4, 2. I want the scale somewhat uniform. Now let's plot points. Negative 2, negative 8. That's down about there, I think, if we... That looks pretty good in this, what I'm seeing. And 4, negative 1. There's my second point. Okay. I'm looking for some confirmation of okay.
Oh, I'm sorry. Yes.
And a nod. And now as I join those, notice what happens to my line. It is going uphill like I thought. Hence what kind of slope? A positive slope. So if I find the slope out of here, it should come out what? A positive. Now what's difficult about this? A whole lot of negative signs running around. Were you asked to get the slope here? Mm-hmm. To calculate the slope?
Yeah, that's all you were
Find the slope of
asked.
the line going 3.
Okay, so if I do that, m, now I'm not going to write the equation at the moment. Y sub 2, y sub 1.
Right.
Yes.
So negative 1 minus negative 8. Then what? X sub 2, 4, minus a negative 2. So minus 1 plus 8, 7. 4 plus 2, 6.
So is that 7, 6 now should be where on this graph?
It is, okay, it reflects. You aren't going to see it in the graph per se unless you draw a what? A triangle. You moved how far to the right?
6.
6, correct? So your run was 6. Then what happened to your rise? 7. So if you want to see it in your graph, it's the 7 over the 6. Now, what makes the problem a little bit easier? Keeping your P1 and your P2 in the appropriate reference. P1 on the left, P2 on the right. Perry?
So use a larger set of numbers, the ordered pair for the P2.
Yes, well,
I use the, okay, I look at the x's.
Right.
The x that's most to the left I call P1. The x that's on the right is going to be P2. So an x of minus 2 is on the left of an x of 4 on the number line. So I think of a number line, and I ask, where is 4? 4 is here. Where's minus 2? It's here. Which one's to the left?
minus
The minus 2, so this becomes P1, this becomes P2.
Okay.
That is my general orientation. And the notation then works for me. If I mess them up the other way, it's too easy to get confused. And it's very subtle, and the author does not take care to be consistent, because the author goes back and forth with the idea, it doesn't matter.
Well,
Well, it doesn't.
Well, it does
That's what
say
says
that
in the
just be
book, and my
consistent.
answer came out.
Yeah.
No, it works.
Yeah,
You'll get negative 7 over negative 6.
And you change it to 7 over
Ah, but
6.
isn't negative
That's what I
7
thought.
over negative 6? 7, 6.
I got 2. It was.
And it's better to write negative 7 over negative 6 as 7 over 6. It's not a necessity to do it the way I'm asking. But I do know this, there'll be fewer questions, and you will have more consistency and less confusion. That's a goal I have, less confusion. Okay. We're just going to do more problems in 3-3.
Okay.
So as we come back up to here, so far, this is all material in section 3-3. And what I'm going to do is now select an exercise from here in general. We're going to start with 1. And we think in terms of perhaps going up through. I want to see how far I want to go. I think just up through numbers. I have no desire to get into there. So let's go 1 through 48, odd. Now some of those you've already done, correct?
Yeah.
16 through 25 all for today. Don't do those again. Okay. So we're thinking of 1 through 48 odd minus the group from 16 through 25. If you didn't have success with the slope problems, then take the time to do it again, if that helps. Is there any question regarding the homework?
On those,
What?
on those 16 through 25,
Yes.
I didn't graph them because
Neither
it
did
didn't
I.
say to graph them.
I know, but I asked you to graph them.
I know.
Okay, so if you didn't graph them, then redo them and graph them. With that, dire straits, and I hope that's not what you're feeling today.
Well.
What is your choice there as we close out, Ernie? What?
I can use the practice anyway.
Louder.
He said.
Okay, ticket to heaven. We'll go back with it. Have a pleasant weekend.